Can you have a look at these two number lines and tell me what you think the arrow could be pointing at?
1.2.
Why do you think that?
Because so you need to like estimate if it's closer to the 1 or if it's closer to the 2, and then so it's obviously closer to the 1, so you start from there and then you can like approximately tell how much more there is.
Good, thank you. Okay. If I wanted to know exactly what it was pointing at, how could you work out, what would you do, what could you think about that would tell me exactly what the arrow is pointing to?
You might want to work out like other numbers around it. So like that one would probably be 2. Like a little bit after that, it would definitely be 1.9 because it goes up.
Okay, so you're labelling all of these points on the bottom number line?
Yes.
Yeah? How do you know what to label them?
Well, let's say 0 and 6. Halfway between it would be 3 because that's how numbers work.
Yeah, so you want to label that one as 3?
Yes.
Okay. Are there any other numbers you can label on either number line?
Well, if it's 3, then this one would be 5.
Why would it be 5?
Because half of 6 is 3, what you're saying, and then half of 10 is 5 as well, so you've got to like...
So they both meet up? They're both half?
Yeah.
Are there any other points you can match up? So you've matched up the zeros, you've matched up the halfways, and you've matched up the 10 and the 6. Are there any other points you can match up on the number line?
The arrow?
Mm-hmm.
I mean, they don't match up, but it goes down to there, and it goes to 2, so that might be 1.2.
Oh, I see. Because this is on the 0.2 here, you think this might be on the 1.2 here?
Yeah.
So if the arrow came down here, and that's on the 3, 1, 2, 3, would you think that was pointing at 1.3?
No. I think it'd be pointing at 1.8 or something. 9.
Yeah.
So you think this one is 1.2, this one is 1.8. What about this one? What would this one point to?
2.3.
I think it's more like in the middle. Yeah, 2.4.
2.4. Okay. And then what did this one point to?
3.0.
No, just
3.0. Okay. What about this one?
maybe
0.6 or 7.
0.7.
you kind of need a number line to work it out properly.
Okay.
Like a ruler to match the thing.
Yeah, we could use a ruler, couldn't we, to measure it? So these numbers that you've told me here, this 1.2, 1.8, 2.4 and 3.0, what do you notice about those numbers that you've chosen?
They all end in an even number.
They do? Yeah, they do. Good noticing, Bimi. They do all end in an even number. What else do you notice?
It looks like the decimals.
They all go up in 6, don't they?
Okay, explain a bit more about that, please.
So 1.2, then you go up to 1.8, which is add on 6, and then 1.8 plus another 6 is 2.4, and then add another 6, and that's 3.0.
Okay,
It's
thank
a
you.
little strange because the 6 is here and they all go up in 6.
Okay. If you agree with what Toby's saying, you weren't sure about this one being 0.6 or 0.7. Do you now feel a bit clearer about what you think you would like that one to be?
0.7.
Why do you want it to be
Because
0.7?
then you would take away 6 from the 1.2.
Do you want to work that out? Do you want to do 1.2? Take away 0.6.
No. No, yeah, that would be 0.6.
Yeah. Thank you, Toby. Thank you for working it out. What might this one be then if we're noticing something?
3.6.
You happy with that? Toby, you happy with that? Where did that 3.6 come from, Izzy?
Because we're going 6 up every time, and 3.0 added 0.6 on would be 3.6.
Good. So keep going then.
So I guess that one's definitely going to be a 1.2 because we've worked out the whole pattern and it all matches up correctly, I think.
Yeah.
Happy with that? So do you think it's a coincidence that you're counting up?
Yeah, I guess, because the n number's 6.
I thought though, just a thing, it would have been 4 because the difference between 6 and 10 is 4, but it's not 4, it's 6.
Oh, so you were expecting these to go up in 0.4s?
Yeah.
So we've shared this 6, this whole 6, out into 10 equal parts.
So that means that 0.6 fits into 10 times, right?
0.6,
Yeah.
say that again, fits into...
10 times.
It goes into 6. 10 times.
Oh yeah, 6 times.
So that would mean it'll go into 10 plus 14 times.
Where did 14 come from? I really like what you said, B-Mate. 0.6 fits into 6 10 times. Good.
Because there's a difference between 6 and 10, that's 4. And then you're adding another 4, 0.6 is on.
Oh, I see. Okay.